Math 2, Unit 5, Lesson 1. So today you should be on page 263 to start with. We are talking about polygons and specifically their interior and exterior angles. Okay, now a polygon is a figure that has 3 or more sides. Because can you have a 2-sided figure? No. So a polygon could be a 3-sided, 4, 5, 6, 7, 8, really to infinity. Okay? So a polygon is a specific number-sided shape. Okay. If we were to figure out, you can figure out the interior angles of any polygon. Okay? Think about a triangle. Okay? How many degrees inside do all triangles have? Okay. So what happens is that I know that a triangle has 3 sides, and you're always going to end up multiplying by 180. What would I need to do to 3 in order to make it so this would equal 1, and when we multiply it times 180, I'd get the answer of 180? 3 minus what makes 1? 3 minus 2 makes 1. Okay? And 1 times 180 equals 180. Now, why I use this example is that we know a triangle has 3 sides, and we know that all triangles multiply to be 180 degrees. Okay? Now, there is a formula, and the formula is this. It is that you go n minus 2 times 180 will always give you the sum of all of the interior angles. Okay, so interior angles, and n represents your number of sides. Now, throughout this lesson, you probably will want a calculator. If you don't have one, you can quietly grab one. Okay? But this formula will work for any size figure. Okay? So on the Got It problem 1, it says, what is the sum of the interior angle measures of a 17-gon? So we are going to use this same formula, but instead of writing n, we're going to write 17. 17 minus 2 times 180. What is 17 minus 2?
15.
And 15 times 180? 2,700 is correct. So that's how many degrees a 17-gon has inside. So again, all I do is take however many sides, subtract it by 2, and multiply times 180. That's it. Okay, so we are going to move on now to page 264. Are we ready? Okay, I'm going to wait a minute. So, on page 264 now, I want you to look at part B. Okay? So let's read it together, and then I want you to discuss in your groups how you think we could figure out what's going on. So it says that the sum of all the interior angle measures of a polygon is 1,980. How could you find the number of sides in this polygon? So right now, I just want you to talk in your groups. I'm going to give you about a minute to talk about what you think you would do. In your groups, talk about it. You don't know. So they told us that it has, what is it? 1,980. So how can you figure out the size? Well, we just do it. And if it does, I'm going to do divide by 180 and then 1. You're on the right track. You would just keep going through until you found the answer. 1,180. You would subtract 2 and you're going to add 2. Yeah. Figure it out? Yes. So that's, you just keep going through until you found the answer. I know, because I just did it because I tried. Okay. All right, I didn't have time to make it around to all the groups. The correct answer is 13. Okay? So there are a couple ways of figuring this out. First of all, we know that the formula is n minus 2 times 180, and in this case it equals 1,980. Correct? When you're at this point, you have a couple different ways that you could solve. Some of the groups divided by 180 to both sides first. The other way you could do it is you could distribute 180 through here and then solve for n. Which way would you guys like to do it? Divide by 180? So if we divide by 180 to both sides, we have n minus 2 equals, and what did you guys get here? 11. And so in order to find what n is, we have to add 2 to both sides to get n equals 13. Could you double check yourself? What would you do to double check that you have the correct answer? Good. And you'd go 13 minus 2, which is 11, and 11 times 180 does equal 1,980, and so you know you got it correct by plugging in the amount of sides that you think it is into your original equation, right? Okay, here, they want you to find the sum of the interior angle measures of each of these polygons. So what formula will we use to find these answers? N minus 2 times 180. So on this one, 35 minus 2 times 180. I want you to find both of these answers for numbers 1 and 2. And then check in your groups, because some of you will go really fast. See if you guys agree with both the answers. Okay, you guys got them? Okay, so on this one, you should have ended up with 33 times 180. And if you're using a calculator, I'm hoping that you're not messing up on this, but it should have been 5,940. Okay, on number 2, you should have taken 20 minus 2 times 180, and so that's 18 times 180, and that is 3,240. Okay, any questions or anything that you would like me to re-explain on this one? So, do you think this is an important formula that you need to memorize? Yes, so interior angles is your n minus 2 times 180. Interior, n minus 2. Can we do that? N with the n, yeah? Okay. All right, so we're going to move on to exteriors here in a minute. Actually, not yet. Okay. So, we are still on page 264. Okay. An equilateral polygon has all of the same sides or congruent sides. I'm just going to put same since congruence is in that definition. So equilateral means all same sides, all equal or same sides. When you have an equiangular polygon, that means all of your angles are the same, right? So I'm going to put all same angles. Now, when you have a regular polygon, it means both. Regular means you have all angles and sides are the same. Now, specifically, it doesn't mean that the sides are the same as the angles, but all of the angles are going to be the same degree, and all the sides will be the same lengths. Okay? So maybe I should put all angles are the same and sides are the same, so that you know they're not exactly equal. Okay. So if I go back to this 35 gon, and I know that inside all of the angles add to be 5,940. If I wanted to find out specifically how much each angle is, what would I do? Divide by what? 35. If you have 35 sides, you have 35 angles. Okay? And so that's exactly what this formula here is telling you, is that in order to find each interior angle, okay, so each interior angle, all you do is use the same formula, but you divide it by how many sides there are, which makes sense, right? So we know how to find how many degrees are inside, and if you want to separate that evenly to each of the angles, you just divide by how many sides. Okay, so we're going to move on here. Are you ready? Wait a minute. So for some of you, we're staying on page 264 here for this first got it problem. Okay, and so it says, what is the measure of each interior angle and a regular nonagon? Now, first of all, a nonagon. Does anybody remember how many sides a nonagon has? Good. This is 9 sides. Okay. Do we know how to find out how many degrees are inside a nonagon? All of them together. How do we find all of them together? Very good. 9 minus 2 times 180. So let's just go ahead and find that answer out first. 9 minus 2 is 7, and 7 times 180 equals 1,260. Okay, and now to find each interior angle, we're going to take this number and divide it by what? How many sides are there? 9. There are 9 sides in a nonagon, which means there are 9 angles in a nonagon. So we take that number and we divide it by 9, and it gives me 140. So each angle is 140 degrees. Okay, does that make sense? All right, so now we're on to page 265. And on page 265, your pictures look better than mine. On number 2 there, we first need to figure out how many sides does that figure have. If I were counting, you guys, to make sure I don't mess up, I do like little lines as I count along to figure out how many sides it has, and then that way I don't add the same side twice. So how many sides? 12 sides. Okay, so can you go ahead and figure out how many degrees each angle in there has? I'm going to walk around. If you have the answer, raise your hand and I will check it. Oops, I'm sorry. So the correct answer is 150. Do we get it? Awesome. Okay, so let's go through the process. So you first have to figure out how many degrees are actually inside. That is by taking our sides, which is 12, minus 2 times 180, but then you divide by the sides, which is 12, right? 12 minus 2 is 10. 10 times 180 is 1,800 divided by 12 equals 150. Okay, we'll see. Okay, this one. We know a circle has 360. We're not talking about the circle, we're talking about the polygon with straight sides. How many sides does that polygon have in there? Good, 5 sides. Find out how many degrees each one has. I'm sorry. You got it? Okay, what's your answer? Good, did you get the same thing? Good. All right, the correct answer is 108. It sounds like most of you have found it because you're talking. So, 5 minus 2 times 180 divided by 5. 5 minus 2 is 3. 3 times 180 is 540. Divided by 5 is 108. Any questions or anything that we need to re-explain? So far, so good? All right. So moving on to page 265, or towards the bottom of 265. I guess you're already there. If you look there at the got it problem, is this a regular polygon? No. Then the reason is you can see that the angles are not all the same. In a regular polygon, each angle has the same degree. Now, but all polygons, whether they're regular or not, depending on the number of sides, have the same amount of degrees. Could I figure out how many degrees are supposed to be in the total polygon? Yes. How many sides does this polygon have? It has 4 sides. So in order to find the total amount that the interior angle should equal, is we go 4 minus 2 times 180. What is 4 minus 2 times 180? Good. 2 times 180, which is 360. How could I now find what that missing angle is? Very good. Add the degrees that you have here. So that means I'm going to go 120 plus 85 plus 53. And I add up all the angles that are there, and what does that equal? 258. And now that I have that, what do I do? Okay, and so I added up each of these angles, right? And we know the whole thing is 360. And so we go 360 minus 258. And we find that my missing angle is 102. Because if this is 102 right there, if you were to check and add all of them together, it will equal 360. So my answer is 102 for measure angle G. Do we have questions? Okay, so without even doing too much math, do you know how many degrees should be inside here on number 5? How many degrees? 360, because all 4-sided figures will have 360 degrees. Because if I go 4 minus 2, it's 2, and 2 times 180 is 360. It will always be, every 4-sided figure inside has 360 degrees. Now, if we add each of these angles together, if the h doesn't have a number, it has a 1. So if we add 2h plus 2h plus h plus h, how many h's? Good. 6h is correct. So 360 equals 6h. What would I do to solve for h? Good. Divide by 6. And we get h equals what? 60. Okay, now it says find the missing angle measures. Well, all of these we don't have the angle measure written. So for 1h, 1 times 60 is 60. For 2h, we would have to go 2 times 60. And what is 2 times 60? 120. So this 2h is 120. The other 2h is 120. And this h is 60. And how could I double check that I have the correct answers? Add them all up and they should equal 360. Okay. Questions? Am I going too fast? No? Okay, what are we going to do on number 6? What's the first thing you should do? Count the sides. How many sides does it have? 7 sides. And like I said before, when you're counting these, I would do little marks as you add around to make sure that you don't add a side twice. Because it's very easy to make it an 8 instead of a 7. Okay? All right, so now that I know that it's 7 sides, what will I do next? Good. Do your subtracting 2 to find out how many degrees should be inside that figure, right? So we'd go 7 minus 2 times 180, 5 times 180, and when you multiply that, it equals 900. Now what? Good. The only thing that's missing is this y, right? So if we add all those, and then what will I do? Subtract it. So if I add all those together, what did it end up equaling? 755 is correct. And so to find our missing angle, we go 900 minus 755. And we end up getting 145. So that means that y equals 145. Good. To get 755, I went through and added. So I added 120 and 116 and 129 and 130 and 135 and 125. And I added those up and that equaled 755. Okay? All right. Are we good? Okay. Page 266. Okay, what's pretty cool about exterior angles is that all of your exterior angles will always add to be 360. How you find exterior angles is, see here, you have a triangle. Okay, I'm going to just draw this triangle here. Your exterior angles is when you take this line and you bring it out, okay? Those are the exterior angles on the outside. For any figure, these exterior angles will always add up to be 360 for any shape that it is. Okay, for any, however many sides, will always add to be 360 degrees. Okay, so let's make a note here so that we do not forget, and that is that all exterior angles will always add to be 360 degrees. So staying on page 266, okay, it says, what is the measure of an exterior angle? So it's asking for an exterior angle, which means one exterior angle of a regular nonagon. How many sides does a nonagon have? Okay, so we know that's 9 sides. Well, in order to evenly distribute it, we would just take our 360 and divide that by 9. Just like there's 9 sides, there's 9 interior angles, there's also 9 exterior angles. So we take 360 divided by 9, and that makes 40. So each exterior angle is 40 degrees. So remember how I said interior is n, meaning we have to do the n minus 2? Exterior, do you hear any n in exterior? No. So we know we're not going to, that's the one that's going to be 360 degrees. Okay? So on this one, a 36 gon, how many degrees does the exterior angles add to be? 360, and to evenly distribute it, we're going to divide that by 36. And 360 divided by 36 is 10 degrees. What will we do on number 8? 360 divided by 100, and that divides to reduce to be 3.6 degrees. Okay, you'd move the decimal here 2 times for 100. It's 2 tens. Okay. All right, we're going to do a couple lesson check problems here. So if you can turn to page 267, lesson check number 9. Okay, so this is the whole lesson. Make sure you're paying attention to see if it says interior or exterior. So it says, what is the sum of the interior angles of an 11-gon? So do I have to use my formula on that one? Yes. So how would I write this out? Interior means we're going to go our n minus 2 times 180. What is n? 11 minus 2 times 180. 9 times 180 equals 1,620. I see people not writing anything down. Okay. Number 10, it says, what is the sum of the measures of the exterior angles of a 15-gon? Did I ever say interior? No, so I'm not going to use my n formula. What's the sum of all exterior angles for any size figure? So guess what my answer is? You guys actually have a test question that says, what is the sum of the exterior angles of, like, a 15-gon? It's that easy. The answer is 360. Okay? All right, next one, number 11. This one says, find the measures of an interior angle and an exterior angle of a regular decagon. What is a decagon? How many sides? Good job. 10 sides. Okay, so we're going to have to do 2 different problems on this one. So let's start with the more difficult one, which is interior. And how do I write that formula for a 10-sided figure? 10 minus 2 times 180, and then I'm going to divide by 10 because it wants an interior angle. So it wants a specific angle. Okay? What is 10 minus 2? 8. And if you go 8 times 180, that equals 1,440. And we divide by 10 to get 140 for each interior angle. Okay? Now, let's do the exterior. What will I do to find the exterior? 360 degrees divided by 10 equals 36 for each exterior angle. Now, the cool thing about this and the way to check is that your exterior and your interior angle, those should add to be 180 because they should make a straight line. And is 144 and 36, do those add to be 180? Yes, so that's the way of double checking your exterior and interior is correct. Okay, 12 and 13 are kind of like one of those mind puzzle kind of things. But vocabulary, can you draw an equal angular polygon that is not equilateral? So can you have something that has equal angles but not equal sides? And the answer is yes. And an example would be a rectangle. Because a rectangle, it has all equal angles, right? All those are 90 degrees, but the sides are not equal. You know, this side is equal to this one, and this one is equal to this one. Okay, and on 13 it says, which angles are the exterior angles from measure angle 1? Which ones are the exterior angles from measure angle 1? Remember, they have to make lines. So measure angle 2 is an exterior angle, and also measure angle 4. It can be drawn either way. So I'm just going to put measure angle 2 and measure angle 4 are exterior angles. Okay, and yes, they would have the same measure. And the reason is, just so you know, is that these make straight lines, okay? They make supplementary angles. So it's that 1 and 4, and also 1 and 2 are both supplementary. Any questions?